Alright, I haven't uploaded in like a year, but quick little video. Stewarts Theorem, its proof, and its applications. I don't know which happened. Okay, so on my screen, my Google Slide's kinda acting up. I hope you can see this laser pointer, because it's being a real mess right now. Anyway, Stewart's Theorem is the relationship between the sides of a triangle, A, B, C, and a cVan, AD. A cVan is a line drawn from one vertex to some point on the opposite side. So from here, cVan A, D is on the line BC, makes sense. If we call BDM, DCN, just like the alphabet, MN, and then we draw our classical, this is side C because it's opposite of angle C, side B opposite of angle B, we get this nice little triangle. A lot of different names for the sides and stuff. You can find the length of any one of these sides by using the lengths of the others. Stewart's theorem is the relationship between the sides, which is known as man plus dad equals bomb plus sink. A man and his dad put a bomb in the sink. You could shorten that down to something much less memorable, but this sort of fun stuff is. Alright, so this is an AMC problem that takes use of the Stewart's theorem. Highly recommend pausing this and trying to do it yourself. I mean, I couldn't do it myself, but who said I was going to pass the AMC anyways? Which I am. We'll see. I'll make an update video about that. What am I saying? My first video was so professional, and look at me now. Look at me now. Anyway, yeah, pause the video, do it yourself, see what you can get. Moving on to the answer in 3, 2, 1. The answer. Basically what we want to do is construct a little triangle out of these, the points, the semicircles. The, center of each one. Make that little triangle, and you'll notice PC looks an awful lot like AD. That looks an awful lot like a cVan. That's because it is. You can measure each of these sides in terms of R, 1 plus R, because this is the 1 plus R. Yes, okay, I'm being dumb. R is the radius of semicircle P, not semicircle, full circle. And then B, the radius of B is 1, so 1 plus R. C, the radius of C is 3, and then this is R. I mean, you get the idea. Then you can do some good old algebra. Man plus dad is equal to bomb plus sink. Man and his dad put a bomb in a sink. Work it all out with your pen and paper. Ba-boom, 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 ba-boom. 6 over 7 is equal to R. And if I remember correctly, that is B. Yes. Alright, this is the proof of the, what's this thing called again? Stewart's theorem. God, I am a bad teacher. So, the proof uses the law of cosines. C squared equals A squared plus B squared minus 2AB cosine of C. Yeah. You can define C squared to be M squared plus D squared, these two things, minus 2MD cosine of the angle in between them. B squared is equal to N squared plus D squared minus 2ND cosine of the angle in between them. We're going to call these, this angle theta, and then this theta prime. So yeah, ADC is going to be theta prime, ADB is going to be theta. One thing to notice about these two is that they are supplementary angles. They both add 20. This is a good time where you could probably try to pause it, finish the proof, see if you can prove that man and his dad put a bomb in the sink relationship. If you don't want to, fair enough. I mean, I don't want to. So, we're gonna click the next key. But bam, rest of the proof. Cosine of theta is equal to negative cosine of theta prime. That is, because the angles are supplementary, you can prove that on a unit circle. Because, just go a unit circle. Very easy to prove. Anyway, from this, we can define this little equation, second one. We can, define it as plus 2ND cosine theta. Now we have both equations in terms of cosine theta. What can we do? Well, easy. We can multiply this one by m, multiply this one by n, and then add them. So that we can just completely remove the 2md cosine theta and 2nd cosine theta. So it'll be 2mnd cosine theta minus 2mnd cosine theta, blah, blah, blah. You get this. b squared m plus c squared n equals nm squared plus nd squared plus mn squared plus md squared. Easy enough. Factor mn out of these two. Factor m plus n out of these two. Wait, you notice you can factor m plus n out of these two. Get over here. b squared m plus c squared n is equal to m plus n times mn plus d squared. Blah, 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 blah. Expand that. I don't know, carry to the 1 or whatever. Man plus dad is equal to bomb plus the sink. The wonderful relationship we were looking for all along. This is my little source page. We got the source for the AMC problem. We got a Wikipedia article for Stewarts Theorem. The art of problem solving for Stewarts Theorem. Stewart's got. Here we have the discoverer. Well, I don't actually know if he discovered it, but he was the first guy to publish it in a book. It was published in 1746 by the mathematician Matthew Stewart. Never would have guessed. I made the equations in latex and the graphs in asymptote. Asymptote is like a vector drawing thingamabobber. Latex, well, you probably know what latex is. Anyway, that's the end. Thank you for watching. Sorry I haven't uploaded in a year. Sorry all of my other uploads are going to be super unprofessional like this one, but being professional it's a lot of work. Alright, later guys. Having to go and close my OP.